Today's lesson is on L'Hopital's rule. Most students like this rule because it gives us a chance to go back to limits, and we all like limits because they're pretty easy. So the conditions of the rule start with this. If we've got these two functions evaluated at c, if they both equal 0, and then if the derivative of f at c and the derivative of g at c exist, and if the derivative of g of c doesn't equal 0, then the limit as x approaches c, so as x approaches c, of f of x over g of x, if they both equal 0, so if when you evaluate using direct substitution, if you get 0 over 0, that is called of indeterminate form. So if you get this indeterminate form, then you could do this. You can evaluate the derivative of f at c and the derivative of g at c to solve this limit. So once again, basically, if you are evaluating a limit, and when you evaluate it, you get 0 over 0, you can just take the derivative of that numerator, derivative of that denominator, and then evaluate the limit and see if you can still get the answer. And you can do this multiple times until you get it to work. And then, so this is once again called of indeterminate form, and it actually works for 0 over 0 or infinity over infinity. Okay, so let's do a few examples so you can kind of see how it works. The first one, limit as x approaches 0 of sine x over x. So if I substitute x in, I will have sine of 0 over 0. Sine of 0 is 0 over 0. So I have this indeterminate form. And notice how I'm using arrows instead of equal signs, because you just have to be careful, because this limit right here, it has an answer, a value. So we don't want to say that this equals 0 over 0 because that gets kind of confusing. So we're just showing that when you do direct substitution, you get this of indeterminate form. So now we have to use L'Hopital's rule. So all we need to do, let's take the derivative of sine x, which is cosine x, and then the derivative of x, which is 1. And now let's evaluate that limit. So cosine of 0 over 1, cosine of 0 is 1, 1 over 1 is 1. Okay, let's do another one. The limit as x approaches 0 of the square root of 4 plus x minus 2 over 2x. So first you want to show that it is of indeterminate form. So if we plug in 0, so on the top we'll get square root of 4 is 2 minus 2 is 0, and then on the bottom is 0. So because it's of that form, we can use L'Hopital's rule. So I know I'm going to have to take the derivative of the numerator, derivative of the denominator. So just kind of off to the side, I'm going to show the derivative of that numerator. So let's see, I'm going to rewrite the original as 4 plus x to the power of 1/2 minus 2. And then we can use power rule here. So derivative, I'll have 1/2 times 4 plus x to the power of negative 1/2 times the derivative of the inside, which is just 1. And I'm going to rewrite that as 1 over 2 square root of 4 plus x. So now I'll rewrite the whole limit as x approaches 0. And then I'm going to write the derivatives of both. So 1 over 2 square root of 4 plus x. And then derivative of the denominator is 2. So now let's try plugging in 0. So up top, I'll have square root of 4 is 2 times 2 is 4. So I'll have this 1/4. And then dividing by 2 is the same as multiplying by 1/2. So this will equal 1/8. All right, so the next one we'll evaluate the limit 2 different ways to kind of do one little review. So limit as x approaches negative 5, x squared plus 2x minus 15 over x plus 5. All right, if you plug in negative 5, so we have 25 minus 10 minus 15, negative 5 plus 5, so I will have 0 over 0. Now, if you remember back from Unit 1, let's try to factor this. So this would factor to x plus 5 times x minus 3 over x plus 5. And let's not forget that we write the limit as x approaches negative 5. So I can eliminate here and then plug in negative 5 minus 3, which is negative 8. So the old method, I mean, that still works, but let's also try using the same thing with L'Hopital's rule. Okay, so let's take the derivative. Limit as x approaches negative 5. Derivative of the top, 2x plus 2. Derivative of the bottom is 1. So now plug in negative 5. Negative 10 plus 2 is also negative 8. All right, limit as x approaches 0 of 1 minus cosine x over x squared. So 1 minus cosine of 0. Cosine of 0 is 1. 1 minus 0, or 1 minus 1 is 0. And 0 squared is 0. So let's take the derivative. Okay, derivative of the numerator. So there's negative 1 and then negative sine x. So that would go back to just positive sine x. Derivative of the denominator is 2x. Okay, let's plug in 0. Sine of 0 over 2 times 0. We get 0 over 0 again. What that means is, now let's do L'Hopital's rule again. So now, limit as x approaches 0. Derivative of sine x goes to cosine x. Derivative of 2x is 2. So cosine of 0 over 2 is 1/2. So you can do L'Hopital's rule more than once. You kind of keep doing it until you can evaluate it. Okay, last example. So let's look at limit approaching infinity. So a limit as x approaches infinity of x to the 5th over e to the power of 5x. So if you are, imagine substituting in infinity. In the numerator, you would have infinity. In the denominator, you would have infinity. So before, when we had these questions, we would have to think, Okay, is it growing larger, like quicker in the numerator or the denominator? And then try to think of it that way. But we're going to use L'Hopital's rule for this one. So this is still of indeterminate form. So let's take the derivative. Okay, so limit as x approaches infinity of 5x to the fourth over, don't forget chain rule with this one, e to the 5x times 5. So the 5's cancel. So if we substitute in infinity, we will still get infinity over infinity. So now let's do the derivative of these. So the limit as x approaches infinity, so the derivative would be 4x to the third over 5e to the 5x. Okay, nothing cancels, and we're still going to have infinity over infinity. Let's keep going. The limit as x approaches infinity, derivative of the top is 12x squared. Derivative of the denominator would be this, and then times 5, so it would be 25e to the 5x. And we're still getting infinity over infinity. Let's do it again. The limit as x approaches infinity of 24x over 125 e to the 5x. Still getting infinity over infinity. Let's do it again. Okay, so 24 over, this will now turn into 625 e to the 5x. So now when we evaluate this, we will have 24 over infinity, which that equals 0. So you might have been able to figure that out at the beginning to just realize that the denominator is going to grow quicker than the numerator, but L'Hopital's rule can also help kind of prove your answer. So there is your full video on this rule. I usually find, most students kind of like this rule. So good luck with your lesson.